Hi everyone, wish you have a nice day. Let me make a simple introduction about myself. I'm Yen Chang, Year 1 student of Mathematics in Xiamen University, Malaysia. This video is a project of my calculus class, which discuss about the optimization in our real-life problems. I have chosen the topics about the utilization of the space. A government is planning to build a non-agricultural area A, B, C, D into an industrial zone in the shape of a trapezium ERPQ with the upper line EQ and the bottom line RP. So as a government, we must try to maximize the area of trapezium to make sure the optimal utilization of space. So let's see how we do this. Here is the given information where AB equals to 2 km, BC 6 km, AE which is equals to BF equals to 4 km, and something interesting is the locus of this is the locus of parabola. I just simplify it as AF. This parabola is with the vertex A and the symmetric axis is AD. So to make the calculation easier, we just put all these points into the Cartesian coordinate, where A is our origin, and AB is x-axis, and AD is y-axis. After putting all these points into Cartesian coordinate, we have to derive the equation of the parabola AF and the equation of the straight line EC. So let's see how we do this. We all know that the general equation of parabola is y equals to ax squared, which vertex is at the origin. So we also know that the point F is on the locus of this parabola. So what does it mean? Actually this means that the coordinates of F must justify this equation. So we could just get the value of A by substitute the coordinates of F. So after substitute the coordinates of F into this equation, we get that the value of A is equals to 1. So after that, we just get the equation of parabola AF is y equals x squared, where the domain is 0 to 2. So after derive the equation of parabola, we need to look at the straight line. So we all know that if we want to form an equation of the straight line, we have to know about the gradients of this straight line. So the gradients of straight line EC, which I denote by MEC, is equals to YC minus YE divided by XC minus XE, where YC equals to BC and YE equals to BF, and SC equals to AB and SE equals to 0, which after that we get the gradients of straight line EC is equals to 1. So we just get the equation of straight line easily, which is y equals to x plus 4, and the domain is same with the domain of the parabola, which is 0 to 2. So after get the equation of the parabola AF and the equation of straight line EC, we can start to derive the function of the trapezium. So before that, we just do a simple revision about the formula of area of the trapezium area. So the area of trapezium is equals to 1/2 times upper line plus bottom line and times the height. And so let's see how we derive the function of the area. So we need to find out the value of RP, EQ, and QP and substitute them into this formula, and we could just easily get the function of the area. So what is RP? So we know the height of R. The height of R is equals to x plus 4, and the height of P is equals to x squared. So RP is equals to x plus 4 minus x squared. And let's see about the EQ. So EQ is equals to EA minus AQ. So EA is equals to 4 kilometers and AQ is actually equals to the height of the parabola, which is x squared. So we just get EQ by 4 minus x squared, and the QP is the most easily to be get. So this is QP is equals to x. So now we have get the value of this line segment. So if we want to get the area function, we just substitute this value of the line segment into the formula of the trapezium. So after that we get a area function as x equals to 1/2 x times x plus x minus 2x squared. So after get the area function, we could just differentiate this function. So after differentiate, we get the x plus x equals to 1/2 times 8 plus 2x minus 6x squared. So let's see what we have to do next. So to find out the maximum of the area, we need to consider about the three situations, about the endpoint, singular point, and stationary point. The endpoint is 2 and 0, and there is no singular point because this is the x is a continuous function, so we don't consider about it because there is no singular point. And about the stationary point, we need to let the x plus x equals to 0 and factorize it, get the value of x. So now we get the endpoint x equals to 2 and x equals to 0. And we get the stationary point x equals to 4 by 3 and x equals to minus 1. After that, we get our candidates to find out the maximized area, which is x equals to 4/3 and x equals to 2. So why we ignore the x equals to 0 and x equals to minus 1? We know x equals to minus 1 because minus 1 is not in our domain. So we not consider about this. And about the x equals to 0, so we know that the s is equals to QP, which is the height of the trapezium. So when s equals to 0, so that means the area of the trapezium is 0. So that is not possible to become the maximize area. So let's see the next one. So we substitute our candidates into the function, and we just get two different answer, and we compare these two answer. So we get one of the answer is a equals to 104 divided by 27, and when x is equals to 4/3, and we get a equals to 2 when x equals to 2. So that's explicit that the maximized area of trapezium is a equals to 104 divided by 27 when x is equals to 4/3. Yeah, so that means when QP is equals to 4/3, we could get the maximized area. So we have done. So thanks for the watching. If you like my video, could you please just click the like button. Okay, see you.